So this turbine shop is actually a really good example of what we've been through in terms of our transformation over the last few years. So this turbine shop was originally designed and operated to repair frame parts. So it was doing 501s, E-class, F-class, you know, the GE machines. It was also doing the Siemens machines, and we repurposed it for aeroderivative. So there were some major changes and then some, you know, smaller changes, because in the end, a lot of the materials are similar between the frame machines and the aeroderivative. There are some very unique differences. Everything's a little bit smaller, but we've taken advantage of that as well. So I'll point out a few ways we've taken advantage. So for example, we have a large CNC, so a VTL, as well as a large horizontal boring machine. An aeroderivative shop wouldn't normally have those, but those are big enough that I can machine our casings, right? The FPI area is not just for parts. I can FPI casings of the 6000. So there isn't a 6000 part on the machine that I can't clean, inspect, and work on. And that's partially because some of the equipment is sized for, for large industrial. And so that's an advantage. And then we also have a number of pieces of equipment that are more for the smaller derivatives. So an example, I needed some floor space, so I sold the X-ray machine. The X-ray machine is a lot more valuable for the big, large frames. Really not a lot of X-ray, right? So this shop does 4 primary things. We have a materials lab in the shop. We do clean and inspect in the shop. We do machining, especially repair machining, and then we do actual repair. So the repair includes the welding, coating, and heat treatment. Okay, so we'll take a quick look inside and see what we got. Okay, so over here to I guess my left is our materials laboratory. So within the materials laboratory, we can do tensile, stress rupture, we can do all the mounting, polishing, etching, all the work you need to evaluate, prove out a material, make sure that your source materials meet your manufacturing requirements. It also allows us to do some material investigations. Fairly standard, but in this part of the materials laboratory, we have our scanning electron microscope. We also have our optical microscopes. We have our hardness machines. But with the scanning electron microscope, including its EDAX functionality, which is the material identification functionality, we can actually do our own failure investigations. So we can look at cracks, we can do crack initiation studies, we can do crack growth studies, we can take the material off a magnetic chip detector, wipe it on. By the way, coffee filters are really good. You know, wipe it on a coffee filter, send it up. We can evaluate, determine whether that's dirt, bearing material, seal material, combustor material. So we can do all that material evaluation. So we don't, as a general rule, we don't sell our investigation capabilities as a service. However, it's incredibly beneficial to our own machines, our own internal activities, but also to qualifying processes. So if you want to qualify a coating, qualifying a weld, we can do all the cut up, all the material checks. We can do everything ourselves within our own materials capability here in the facility. What's behind you is the back of a machine, but this is our small machining area. So we have our lathes, mills, we have a plunge EDM, and then you'll see we also have some manual machines. So manual machines are very important to a repair shop, okay? Because CNC machines are wonderful and incredibly productive if you're going to do the same thing over and over. When you're repairing, sometimes you're doing it once, right? Or the part repair varies enough that it requires that manual interaction. So the manual equipment is also incredibly important, and you've got to have the people who really know how to use it, right? So this is the small machining area. We'll hit a few of the others. This happens to be one of our brand new machines. This machine just arrived about 2 months ago. So as part of investigation, we have our CMM. So this is a coordinate measurement machine. We also have blue light scanners and other scanning equipment. The way I look at a blue light scan versus a CMM. So think about your weather map, right? So if you get a weather map on the news, it's got this pattern, right, of all the reds, yellows, greens. That gives you the delta of the temperature, right? But to know the exact temperature, you need a thermocouple, right? Or a thermometer or something to give you that exact temperature. In the measurement world, right, a blue light scan or another scan, that gives you the profile and the delta, right? The CMM gives you the exact measurement. So this is a computer controlled system. So for example, on the disc, on one of our discs, we have what's referred to as the armpit region. That armpit region tends to thin out. So when we overhaul that disc, one of the things we have to do is detailed measurement of that armpit region to make sure it's within specification. And that's all done by CMM. So the CMM can go in, reach in, and do all those measurements and make sure that that part of the disc is within specification. It can also take one of those scans and we can do a series of small points on it with this, and that'll set the datum or the base number, which allows you to understand what the deltas in the scan mean. All right, so that's how a CMM is used regularly. The next part of the shop is sort of the clean and inspect area. So one of the things we did was we completely rebuilt our clean line. So that's in here. So not everybody's going to show you their clean line, right? Because the clean line's not as exciting, let's say, as some of the other parts of what you do. But here's the thing with the clean line. So we changed the clean line from what we did in the past with the large frame equipment, mostly because the approach to the aeroderivative parts is a little bit different. But we made sure that all the alkalis, all the soaps, all the different treatments that are required for cleaning the aeroderivative parts was set up in our clean line. And what's most important is if you're going to inspect any customer's part or your own part, and you want to make sure that that part is inspected properly, it has to be cleaned first. So you clean it again, you clean it a third time if you need to. If that doesn't work, you take it to the blast booth, you blast it, and then you clean it again. Because you want to make sure that when you inspect it, you're inspecting the real part, right? So it's incredibly important. We gutted this whole facility and completely rebuilt it as part of our move to the aeroderivative part of the business. So this was a big transformation area. Once it's clean, we take it to the other part of our shop. We go to inspect. So our inspect area, we have a series of inspection techniques. So we can do all the mechanical inspection, we can do FPI, we can do mag particle, we can do eddy current, and we can also do immersion UT. So we have all of those different inspection techniques. The FPI line, we have both an immersion line as well as a spray line. The spray line allows us to do large parts. The immersion line allows us to do much more detailed work on smaller parts. And then we have the mechanical area. Mechanical area uses lots of calipers, lots of other equipment, but we also have a brand new ferro arm. You can see the ferro arm in use right now. I like to refer to the ferro arm as something that's kind of like Stargate. If you ever watched this movie Stargate, they always said, you know, you need 7 points to define any position. A starting point, a transfer, right? A starting point, and then 6 points to define 3D space. What the ferro arm does is give you 2 points in three-dimensional space. And it does it very quickly. So you can measure concentricity, you can measure whether it's round, you can measure whether it's concentric to itself, and you can do it on relatively large parts. You can see he's doing an LPT frame right now. And that LPT frame would normally take hours to inspect, and the ferro arm allows us to get that down to a much shorter period of time. Okay? Right next to you, although it's a little out of order, is our Huffman laser welder. So the Huffman laser welder, we use it primarily for hard coat. So if you look at the large blades in the LPT, they have Z-locks, so Z-notches where the tips of the blades lock together. You laser treat the surface of the metal, and what that does is it gives you a hardening of that surface. So when the two touch and rub against each other, you've got a hard surface versus the more pliable surface in the rest of the part. So the laser welder allows us to do that on our new make and our repair of the LPT blades. Okay, and we'll talk about that a little more when we're in the other shop. I should mention that this machining area, including the large machines at the back, not only do machining for repair and for the gas turbine, but we also do some machining for the package. So one of the advantages of being as vertically integrated as we are on site, doing all the packaging work and the engine work, is we can make sure our equipment is utilized heavily. So if there's any, if the machines are needed for repair, then we pull them for repair. If they're not busy on repair, then they're making parts for our package for the shelf and for inventory and for projects. So that means we keep our equipment busy all the time. It also gives variety to the guys running the machines, which also is really nice. It's tough to make the same part all day, every day for months at a time. So from an inspection standpoint, we use what I like to refer to as more of an aviation philosophy. We can argue the philosophy, but what we do is when we inspect a part, we're looking for anything we can find. It doesn't matter whether what we find is needs repair, doesn't need repair, scraps the part. It doesn't matter. We look for everything. We mark everything that we find, no matter what the inspection technique. Then it comes to the inspectors' desks. The inspectors, they take those findings and they compare them to what's allowable. So is this allowable to run as is? Does this require repairs within limits? If it requires repair, then they flag it. That same system, we call it our MRO system, that we put all the parts in, also has all the operations in it for repair. So when we find something on the part, the inspector defines a repair, that loads all the traveler steps, and then it goes through the shop, and as each individual completes their step, they check it off in the system. When all of those steps are complete, the part comes back here, gets inspected another time, and then is issued a COC, or Certification of Compliance, which is exactly what we require from all of our external suppliers. So every part that's been repaired or inspected has a Certificate of Compliance, which says it's ready to go back in the machine. So in the back part of the manufacturing area, we have a series of machines. We have 2 VTLs, vertical turning lathes. We've also got an HBM. As I mentioned, the VTL and the HBM are large enough to take large casings. They can do the full grind on all the shrouds. Our smaller VTL also has an electro spark, which allows us to machine honeycomb if we need to. We also have an EDM hole popper around here to the side, which allows us to EDM out holes in blades if there's blockages. And then we have our new Haas 4-axis machine. The Haas 4-axis machine allows us to use multiple pallets within the machine, so we can machine multiple parts at the same time, and it can run for long times unattended. So this was a large productivity add to the shop, and something we added just roughly a year ago. These machines at the back, again, are the ones that enable us to do those large casings like we talked about before entering the building. Similarly, and you can see a turbine rear frame. On this side, this is more of the repair. So as we start looking at the repair in the materials area, we've got our furnaces. So we have an oven for lower temperatures, then we have 2 vacuum furnaces. They're large vacuum furnaces. We actually considered buying a smaller one, but the reality of it is we invested even more in the overhaul of these machines. The overhaul of the machines made sure that they operate reliably. We have all our traces. We have clear productivity and quality control. But what this allows us to do is do all our internal heat treatments. They're large enough that we can heat treat a complete turbine rear frame. So rather than having a small machine that would allow us to do small parts, we have a larger machines that allow us to do large parts or multiple sets of small parts. So it's an enabler more than a high efficiency play, right? And that's why we kept and put the overhaul in these machines. Now, what do we use the vacuum furnace for? So we use it for recovering material. We use it for stress relief. So if you think of stress relief, we do a lot of welding and brazing. So if you get a cut and you get a scab on your cut, your skin pulls, right? So if you weld metal, the skin pulls, right? Just like it did on your hand. And when you heat treat it, you can relieve that stress, right? And that takes the stress out of that. You can also diffuse alloys. So if you do brazing or welding, you can actually diffuse the weld or braze alloys into the base metal and join them even more effectively than just with the initial braze or weld. So the heat treatment's very critical. A repair might have 1, it might have 2 or 3 heat treatments. And so the heat treatment's critical. These are done in vacuum. That keeps air out of it. Without air, the part doesn't oxidize while it's being heat treated. Okay? I mentioned on the cleaning that sometimes you have to blast. So we have our blast booth over here. We have multimedia capability. I'm not going to go too close to it because they're blasting right now and it's a little bit noisy. But that's our final cleaning stage if necessary. Once we've been through that, it's all about the repair. So let's walk up the aisle to the repair area. You can see that casing all cleaned. So you look, this is the casing that we saw on the other side. And I said, you know, once you get all the parts out, you can clean the casing all off. So we have various queues where we manage the parts. You'll see that all the parts are tagged, but they're also, we do a lot of tracking by barcode and QRC code, but we also do paper tag tracking. They queue for various areas, and then they also engineering queue. So when we inspect them or we're repairing them and we find something that might be a little bit out of limits or it might be close to a limit, then that would go to the engineering queue. So engineering would get involved. They do an evaluation. That's within spec. Everything's fine. Or it might be that the evaluation is, we believe this part has a full interval of life, even though it's just slightly out of spec. And so what we would then do is we would use our customer support rep to talk to the customer and to say, this is our evaluation, it's up to you, we can either repair it, replace it, or we believe it's good for a full interval, just use it and save money on your overhaul. And so we do that on a regular basis, and it's one of the strong interactions we have with our customers between that and the repair and overhaul shop. Okay? What you see to your right is one of our new machines. So it's in service as we speak. It's in its annual, but this is our LaserTech 125 3D hybrid.
Oh yeah.
So the LaserTech 125 3D hybrid, this is a machine that allows both additive and subtractive capabilities. And what's unique about the additive, so most people have heard of metal printing, right? So most metal printing happens in a powder bed. So you have a powder bed, you have a laser or an EB weld or something that then builds a part out of the powder, right? Well, this is a DED, so it's a direct energy deposit. That means the powder comes out of the nozzle along with the laser and melts locally. So that means we can deposit it on an existing part. You can't do that in a powder bed. Okay? So that DED capability means if we want to lay down metal on something to repair it, we can in this machine. It also means we can build up a part in the machine from scratch, right? The 125 is what's unique and why we have this one versus a lot of the powder bed machines. There's a lot of printing companies out there and they have print shops. They have 10, 15 printers, right? Very few people have this one because 1.25 means 1.25 meter of platform. So it's a very large table. You can see it's got a V-notch in it so we can lift things in and out with a crane. It has a very fast laydown rate. So it's for large parts. So you wouldn't make a little fastener in here, right? You're going to make big pieces, lots of laydown for material. It's very fast. This was actually number 6 in the world. This machine allows you to do that printing, and it allows very fast product development, right? So if you wanted to do a casting development, and we can argue this, but normally it's between 12, 18 months. The development of a cast part that we did in this machine took us 60 days. So we were in production in 60 days. And what you really want to do is you want to print as much as possible. Now you can subtractive machine as well, so it has a milling head, a 4-axis milling head. Now what that means is if you print the part, you can then machine the datum on the part so that then we can pop it out, drop it into our Haas 4-axis machine, and do all the machining over there in a $250,000 machine instead of machining in a $2 million machine, right? So it gives us that ability to move a part very quickly, hold that datum, know that we're in the right position. So a couple of example parts. Let's see. So this is a rotor, an impeller. So we put a flat disc on there. One of the things you could do is you could machine in here, make all these fins, put the fins in, weld the fins in place, do all of that. But instead we just took a flat disc and printed those fins on. So the fins and all the radius, so you can see the radius in the fin, these radii are all printed and machined. So this part was finished in the Mori. And so that part's a hybrid printed and steel, you know, original plate machine. This is a VBV door. So for those who know the LM6000, between the low pressure compressor and the high pressure compressor, we release air, right? So that you can protect one compressor from the other. The compressor front frame has pressure relief doors. This is a pressure relief door, or a VBV door, right? So this VBV door opens up to allow that air to release. This VBV door was printed in this machine. So we have a metal plate on the bottom. We print all of this onto it. Then we machine all the features onto it. We flip it over and we machine the back side to give the right radius and seal to it. Then we mount our seal on it and we rivet it in place. Yes, that's the finished printed surface, and this is the machine surface. In most cases, this is actually, I actually argued with the guys a little bit, there's more machine surface on here than we need, right? I mean, these don't need to be machined. It's nice, it looks better that way, but really what you need is you need these pinpoints machined, right? And you need the shape machined, and especially the seal area machined, right? So that you get a good solid seal on it. But this was the part, this took us 60 days to develop. We're in production, we've made tons of these. People ask me about material properties. We do a lot of material property testing. You have to make sure that the printed materials are strong. But generally speaking, you know, printing is, how do I say it nicely? Printing is welding. It's just very controlled welding, right? I mean, you're melting powder or melting rod and making another part, right? So this material, based on the metallurgy that we've seen, either through DED or through a powder bed, is somewhere between a cast and a forged material, depending on how well you control your parameters and everything. Well, this was a cast part, so a printed part is, you know, of the same material, is generally stronger.
You guys like order the material and put it all in, or do you mix? Do you do mixing of it?
So we right now we order the powder. So this is 17.4 pH, so we ordered 17.4 pH powder. We can print nickel, so we can print 625, 718, things like that in the machine as well. But it does have a dual feeder system, so arguably I can mix powders
to experiment
and print. And the way I think that would be a value, and we haven't done it yet. The machine's relatively new. We're doing, you know, a little bit at a time. Yeah. We're on our 6th part right now. But one of them is, if you think about this and a bushing in here, you'd like that surface to be a little harder. So what if you change the powder or the printing parameters just a little bit to make this part of the steel harder than the rest of it? You could do that and you wouldn't require the laser hard coating, you wouldn't require a coating on it necessarily to do that hardening. Now this one uses bushing, so you don't need a coating, but there's ways to think about that in ways that you could hybridize a part and do it all in one run in the same machine. So behind you is our, what I like to refer to as Artisan Alley. So behind you is where the welders are. So this is where the welding guys, the brazing guys, the blending, so all the handwork that goes into repair. So when I think about, you know, a super alloy welder, you know, the materials engineer goes, well, look, for that weld, I know you need to use this wire and you need to weld fast and hot. But these are the guys who control the pedal, set the parameters. They're the ones who are qualified to make those welds. And each one, right, has their own way of doing it that's very successful. Now we have to qualify them and make sure that their welds are repeatable and good. And then the other thing is, it's where we do our hand blending. So we blend the parts, we do that. The Q sits in between, but this is really the artisan area. Behind you is our new immersion UT. So this is an ultrasonic inspection on immersion. So we can inspect incoming forgings, we can inspect wheels. It doesn't allow you to inspect well like holes, things like that. That's better with eddy current FPI, those type. But this is a better bulk area type of inspection, and that's one of our newer pieces of equipment as well. So this is our coating and surface area. So in the coating and surface area in the back, we have our new fully automated dual peener. So that's our newest peening system. At the back, we have a semi-automated manual peening system. So we have our 2 peening systems. This one's much better for controlling the peening of turbine wheels, right, where you want to have a very consistent, uniform peening operation. And then we have a number of blast booths. That's because, or blasting, areas. That's because it's a lot easier to have 6, each one with a different material in it, than it is to clean them out every time you want to change blast material. At the back, we have our clean room. The clean room is where we do our brazing. So brazing, for people who don't know, is metal glue, for lack of a better term. You take 2 pieces, like honeycomb is the most common. You'll put a braze paste on the shroud, you put the honeycomb on, you take it up to 2,400 degrees-ish, and the two bond together because that metal adhesive or braze melts and bonds the honeycomb to. If you tried to weld honeycomb, it would just blow through completely. If you tried to machine honeycomb, it would just fall apart. So that brazing technology is very good. You can also braze repair cracks in parts as well. Over to the back to the right is our 2 spray booths. So in our spray booths, we're capable of HVOF. We can do air plasma spray. So we can lay down metal spray. We can lay down ceramics. So we can actually build up parts using metal spray to repair them. We can also do bond coats. We can do the TBC coating. So between our 2 coating booths, we can do every coating in the LM6000 except the EBPVD on the HPT blades, which is actually done by Chromalloy, and they have their own capability to do that for us. But every other coating needed in the machine can be done in these 2 booths. Okay? All right, so that's the repair shop, right? We do have an extension to this, so we'll go to the next building where we do all our fuel nozzle repair and where we do a lot of our new make work. Okay? But I would tell you that anyone who wants to make new parts, even with Amore or with anything else, the abilities of this shop are crucial to that. The ability, all the inspection capability, all the coating capability, the heat treating capability. The fact that that was all here as part of repair is a huge enabler to your ability to make parts, because all those operations are part of the new make as well as part of the repair. These were a productivity play that we did just not long ago. So these plastic containers, they don't seem like much, but they stack together easily. What's more important is the trays. So each tub has a tray in it, and the tray is specific to the part, whether it's a large blade, a small blade. What we did was we did a value stream map, and when we were repairing parts, we had people counting the parts as many as 7 times during the repair to make sure that they were all there, something didn't get left behind, it didn't get lost. Now with the trays, if the parts are in the tray, they're all there. So there's no counting. On top of that, the inserts, these laser cut inserts, will go in the cleaning machine. You don't have to unload and reload the parts. You can clean them automatically. You can also move them around a fork truck. You can put them on a truck and ship them, all safely within this. So this has been a huge productivity play for us as well. Cowl, combustor cowl for the LM6000. The main combustion rings all coated. Nozzles. As an engineer and sort of a technical geek, I love the parts, so it's hard for me. So we have offices for every single shop. One of the reasons we have offices for every single shop is we want people dedicated to those shops. So if you have an engineering crew, right? Let's say you've got 6 engineers. The engineers will tend towards whatever the biggest crisis of the day is, or I would refer to sometimes as shiny object. But if you have repair engineers that are dedicated to the repair shop, you want them sitting in the repair shop, right? You want them on the floor. Any true engineer wants to do what I was just doing, and that pick up parts, look at parts, look at how to make them, how do they go together, how do they come out of the machine, what do they look like coming out of the machine, how do I repair them, how do I make them better, and talk to the guys on the shop floor. Because the one thing I guarantee you is that the engineer and the smartest guy in the shop guy, floor guys are. They know what's going on in the shop better than even the engineers do, right? And that interaction is just priceless. And having the guys right here in the offices in each shop is really critical.